See you next.
That was the second group, stage 3. Now, moving to our final group at the moment. Why at the moment? We have a group that is going to perform its experiment outside. So we are now moving on to the final group as of now. Let's get ready to unravel the mystery with the secret message. Experiment featuring invisible ink.
My name is Peter. I am Joshua. My name is Kiara. And I am Freya. And we are from stage 3. Today we are going to learn how to make an invisible ink. Let's get started. Materials needed: cotton swab, lemon juice, paper, candle, and the light. How to do? How to do? Use cotton swab to dip to the lemon juice and write your secret message on the paper. Let it dry for a few minutes. Once you're ready to give your secret message, take the paper and lick it. Take the candle and lick it. Heat the paper over the fire and see your secret message appear. Almost. How it works. When the lemon juice is heated with fire, when the lemon juice is heated by fire, the carbon compound breaks down. This produces carbon, which is in black or brown in color. Thank you for listening. See you next time.
That was a spectacular performance. Let's give them a round of applause one more time. Now, returning to stage 2, we are delighted to kick off our first group, focusing on how to make a circuit. Get ready Involving the role of electronics as our students demonstrate the step-by-step process of creating a circuit. From understanding components to writing techniques, this presentation offers a hands-on approach on exploration of fundamental electrical concepts. Let's give them a round of applause as they come on stage. We are working in collaboration with preparatory class.
of the light of the world. Thank you.
I will now speak on to another way of communication, the traditional one. Can you hear me at the back? Can you hear me at the back? Okay, thank you. What? I think our problem has been resolved now. Now transitioning to stage 4. We are already on stage. We are trying to introduce our first group presenting the volcanic eruption model. Let's prepare to be transported to the dynamic world of geology as our students showcase their meticulously crafted model, capturing the awesome, inspiring power and beauty of volcanic eruptions. Stage 4, Group 1.
Morning everyone, my name is Ivana Flores. My name is Hassan Al-Basu. My name is Deep Song. And we are from stage 4 class. And we are going to present to you volcanic eruption model. The following materials are baking soda, vinegar, and food coloring. Procedure. Step 1. Using a funnel, pour the baking soda inside the volcano model. Step 2, make some vinegar and food coloring. Step 3, add the mixture inside the volcano model and watch it erupt. Exploration. This experience makes sodium hydrogen. Carbonate presents the baking soda. The vinegar is an acid and the baking soda is a base. The acid and the base combine and a common reaction occurs and releases carbon dioxide. The carbon dioxide rushes to the volcano hole. Thank you.
Well, thank you so much, Stage 4 Group A, for an astounding performance. Next up in Stage 4, we have our second group presenting their project on the solar city model. Let's get ready to embark on a journey through space as our students unveil their meticulously crafted representation of our celestial neighborhood. Over to you, Stage 4.
Good morning, everyone. My name is Ander. My name is Daniela. My name is Mela. My name is Sachi. My name is Luana. My name is Lazar. My name is Fatima. And my name is Shivani. We are from Stage 4 class, and we are going to present to you the solar system model. The solar system. The solar system is a gravitational balanced system that consists of the sun and the objects orbiting it. It consists of one star, 8 planets, and other small countless smaller bodies such as dwarf planets, asteroids, meteoroids, and comets. The sun. The sun is in the center of our solar system. It's also known as our own star. It's a huge burning ball of gas. It's mostly made of the gases hydrogen and helium. The planets. There are 8 planets in the solar system. 4 are terrestrial planets, 2 are gas giants, 2 are ice giants. The rest of the planets are the planets which have rocky solid surfaces. The gas giants are the planets which are made up of gas and the largest planets in the solar system. The ice giants are the planets which are made of ice and frozen. Mercury. Mercury is a rocky sphere, not much bigger than our own moon. It is the closest planet to the sun and the first planet in the solar system. It is about 2/5 the distance between the sun and the earth. This means the sun facing to the sun can get really hot, up to 430 degrees Celsius during the day. Mercury takes 59 days to spin on its own axis. Mercury goes on a short orbit. So, a year on Mercury only lasts 88 days. The seasoning and moon. Mercury has no moons because of its close proximity to the sun. If any moon revolved around Mercury, it would be swallowed by the gravitational pull of the sun. Now, Mercury has no seasons. Why? Because Mercury has no significant atmosphere like we on Earth have. We have found so many records of different things
system between sun and moon, between the sun and earth. It is known as Earth's twin because they have very similar sizes. Venus is the hottest planet with an average temperature of 403 degrees Celsius. The surface of Venus is dry and rocky, with lava flows across parts of the planet. It takes Venus 243 Earth days to complete an orbit of the Sun, but to spin round on its axis, but only 225 days to complete an orbit of the Sun. So a day on Venus is actually longer than a year. Thank you.
Earth is the giant planet of the Sun and the only planet in the solar system with life on it. Our planet is habitable because it's just the right temperature to support life. It also has an ideal atmosphere which traps just the right amount of sun heat to keep Earth's temperature stable. Most structures contribute which Earth has liquid in the surface, which liquid takes into the rock. Thank you. Mars is the fourth planet from the solar system and the last of the radial planets. It is half size of Earth and about 1.5 distance between the Sun that Earth is. Mars has 2 moons. A day on Mars lasts 24 hours and a year lasts 687 days. Why does Mars look red? Mars is often visible, looks like a red dot, giving its nickname the red planet. Why does Mars look red? Mars looks red because its surface contains a lot of iron, and that iron is rusted through oxidation, the chemical reaction when iron meets water and oxygen. Brown to a reddish brown color. Thank you. Jupiter is the 5th planet from the Sun and the largest planet in the solar system. It is about 5 times distant from the Sun, that Earth is at 11 times the weight of Earth. Jupiter is so huge that it is as twice as massive as all the other planets in the solar system put together. Jupiter's crazy appearance caused by winds blowing on clouds of different types of ice, liquid and gas around. Jupiter is known to have 18 moons. A day Jupiter is just less than 10 hours and a year takes 12 Earth years. Saturn is the 6th planet from the Sun and the second of gas giants. It's 9 times the width of the Earth and 9 times further away from the Sun. Saturn is famous for its beautiful rings that extends out about 280 kilometers for the planet. The ring has an average temperature of only 10 meters thickness, as well as these rings. Saturn is orbited by 83 moons. A day on Saturn lasts for just under 11 hours, while a year is about 29 Earth years. Uranus is the 7th planet from the Sun and first of its kind. It is 4 times wider than Earth, nearly 20 times further from the Sun. Because it's so far from the Sun, the average temperature on its surface is only 195 degrees Celsius. It is the only planet with this. A day on Uranus takes 17 hours, while a year takes 84 times an Earth year. Neptune is the furthest planet from the Sun. Neptune is the 8th planet from the Sun and the second of the
some of these letters are becoming more eloquent and more knowledgeable than us teachers. Let's give them a round of applause. Now, moving on to stage 5, we are excited to introduce our first group presenting their project on the digestive system working model. Get ready to walk into the fascinating world of human biology as our students showcase a detailed representation of the digestive process. Through this interactive model, we'll gain a deeper understanding of how our bodies break down food and absorb nutrients. Let's give a round of applause as this next group, stage 5, comes on stage.
Morning, teachers, parents, students, and guests. My name is Alistair.
My name is Edwin.
My name is Kiani. We are from stage 5 class, and today we are going to present the digestive system model and how the digestion happens. The digestive system, elementary canon, is a one-way tube that passes through the body. It starts at the mouth and ends at the anus. It is about 9 meters long and made up of different parts including the mouth, the esophagus, the stomach, the small intestine, the large intestine, and the anus. How does digestion happen? Digestion starts in the mouth. Your teeth chew and chop up the food into smaller pieces that we can swallow. Saliva makes our food moist, which also makes swallowing easy. Digestive juices hit the stomach, but then start to digest the food.
The food we swallow is pushed into tube called the esophagus and into the stomach. The muscles at the esophagus contract to squeeze and push the food downward. Inside the stomach, food mixes with digestive juices which stirs the food into a thick liquid similar to porridge.
The small intestine breaks down the food even more until the food particles are small enough to move into the blood, move into the large intestine. The large intestine also absorbs water back into the blood. And now we are going to demonstrate how does digestion happen. Thank you, everyone.
Wonderful presentation on the digestive system. Now, we have our stage 5 second group, which is let's prepare to immense. The amazing wonders of nature is our students show a dynamic representation of how water circulates through our planet from evaporation to precipitation and everything in between. Stage 5, second group.
Good morning, everyone. My name is Zoya Shakhanani and I'm from stage 5 class.
My name is Lana Karina and I'm from stage 5.
My name is Miriam and I'm from stage 5.
My name is Rahaf Kaur and I'm from stage 5. Today we're going to present how the electric cycle works and the different processes in the water cycle. The water cycle is a continuous process in which the water evaporates from the sea, rivers, and lakes, etc. into the atmosphere where it falls back to the Earth's surface as rain or snow. The water cycle consists of 3 major processes. They are evaporation, condensation, and precipitation.
plants begin with evaporation. It is a process of water at the surface turning into water vapor. Water absorbs the heat energy from the sun and turns into vapor. It is Water bodies like oceans, seas, lakes, and rivers are the main source of evaporation. Through evaporation, water moves from the hydrosphere to atmosphere. As water evaporates, it reduces the temperature of those water bodies.
Condensation. As water evaporates into water vapor, it rises up in the atmosphere. At high altitudes, the temperature changes into very tiny particles of ice or water droplets because of low temperature. This process is called condensation. These particles come close together and form clouds and fogs in the sky.
Precipitation. The cloud or condensed water vapor are poured down as precipitation, though the wind or temperature change. This occurs because the water droplets combine to make bigger droplets. So when the air cannot hold anymore the water droplets, it precipitates. At high altitudes, the temperature low and high. The water droplets lose their heat energy. These water droplets fall down as rain. If the temperature is very low, below 0 degrees, the water droplets fall down as snow. In addition, water could also precipitate on the form of drizzle, sleet, and hail. Hence, water enters the lithosphere by landing upon the earth. Thank you. Thank you, everyone.
Thank you, Stage 5, for a spectacular presentation. Entering now Stage 7, and we are thrilled to introduce our basic group presenting their project on the table of air conditioner. Let's get ready to experience the innovation and engineering prowess of our students as they showcase their understanding of turbocharging and air conditioning systems.
Good morning. Our introduction. Creating a fan out of cardboard can be a fun and creative dye project that not only helps you to stay cool, but also allows you to express your artistic side. In this guide, we will walk through the process of making a fan using simple materials like cardboard, glue, and paint bulbs. Materials needed: 1. Cardboard, 2. Scissors, 3. Glue, 4. Paint and brushes, 5. String or ribbon. This is optional, as you see here we didn't use it. Instructions. Cut out the dimensions. Begin by cutting out a rectangular piece of cardboard that will serve as the base of your fan. Then cut a smaller rectangular section within the base to create a fan blade.
Attach the base folded base along edges to create a folding effect. Glue the folded sections together with glue gun in place. Decorate your fan. Get creative with paint, markers, or other decorative materials to customize your fan. You can paint patterns, designs, or even add inspiration or quotes to make your fan unique. Adding momentum. To make it easier to hold and use our fan, you can attach a string or ribbon to one end of the fan. This will also give your fan a stylish finish.
Creating a fan with wood out of cardboard is a simple yet enjoyable project that can be fun activity for all ages. Not only does it provide a practical solution for staying cool, but it also allows you to showcase your creativity and artistic flair.
So grab some cardboard, let's start crafting
the very specified purpose.
Thank you for listening to us. Before we leave, we have a demonstration for our fans. Thank you.
Thank you, Stage 7, Group 1. Moving forward to Stage 7, we have our second group ready to present their project on telescope. Get prepared to explore the vastness of cosmos as our students unveil their understanding of optics and astronomy through the lens of the telescope. Okay.
From Yent. From Yent.
Good morning, everyone. Today we'd like to give you our presentation about periscope.
What is a periscope?
A periscope is an instrument used for observing over, under, or through an object or obstacle which is prevented to be seen in a direct line of sight. It is also used to get a better view on distant objects. Fact about a periscope.
In 1854, the French scientist Pierre-Marie David invented the first level periscope. The term periscope derives from "p", meaning around, surrounding, near, and see or hear respectively. What are the materials needed to make a periscope? Our periscope there are many materials that can be used to make periscopes, but our periscope was specially made by cardboard artwork, tape, 2 identical mirrors, and glue gun.
So how did we make the periscope? First step, we cut a piece of cardboard in the shape of C with the measurements of 22 centimeters and 16 centimeters. Step 2. Then we cut a large piece of rectangular cardboard with the measurements 38 centimeters and 24 centimeters. Step 3. We cut 2 identical rectangles and 2 identical squares with the measurements 16 by 8 and 8 centimeters. Step 5. We stuck all the pieces together using tape. Step 6. We stuck the mirrors at a 45-degree angle so they can face each other. And finally, the last step. We stuck the top piece on top and the periscope was finished. How do periscopes work? Periscopes use a system of prisms, lenses, and mirrors. Light from a distant object strikes the top mirror and is reflected at an angle of 90 degrees down the periscope tube. At the bottom of the periscope tube, light strikes another mirror and is reflected into the viewer's eyes. This simple periscope uses only flat mirrors, as compared to the other periscopes using submarines, which are usually complex optical systems using both lenses and mirrors. Now I'd like one of the parents to come on stage just so they can try and use the periscope, just to show that it works.
Ask Evans did. Evans did.
Can you come with me? Yes.
Good evening, or good afternoon.
telescope model from State 7 Group number 2. Continuing with State 7, our third group is all set to present their project on electromagnetics. Let's get ready to be magnetized by the fascinating world of electromagnetism as our students showcase their understanding of how electricity and magnetism intertwine to create powerful magnetic fields. Over to you, Group 3.
Good morning, respected teachers, parents, fellow students. My name is
Sorry to interject. That's a special announcement. We have parents who have other commitments and moments and wish to leave. However, as we highlighted earlier on, we have two exhibitions, the science exhibition as well as the arts exhibition. So before you leave, may you kindly go out through that entrance door, just exit. Again, using that door, and you get directions on how you can find your way to where the artistic articles are displayed. Thank you.
Good morning, respected teachers, parents, and fellow students. Today, my name is Gamal Afani, and today I'll be presenting about electromagnetism. What is an electromagnet? An electromagnet is a metal device consisting of a core magnetic material surrounded by a coil through which an electric current passes through to magnetize the core. How does it work? Electromagnets are made of coils with wire with electricity passing through. Moving charges create magnetic fields, so when the coils of the electromagnet have electric current passing through, the coils behave like a magnet. So let me just quickly explain how this works. So first I will insert the wire on both of the terminals of the cell, just like this. Now that the terminals have been connected with the wire, I will now point the nail towards the iron paper clips, just like this. And just like this, it has attracted the iron paper clips onto the nail. What are the applications of electromagnets? Electromagnets are commonly used for several purposes on day-to-day basis, such as generators, doorbells, headphones and loudspeakers, induction cookers, cranes, and many more. Thank you so much for listening and listening.
That was a demonstration of electromagnetism. Now we move on to our fourth group, which is the last group in State 7. Let's get ready as they are presenting a project on the Leyden jar, which is commonly known as the shock jar. State 7 to 4.
Good morning, everyone. Today we represent a Leyden jar.
A linen jar is constituted with a small hole in the top to electrocute if you catch. This thing works by you touching this ball on the top of the jar. If you touch this ball, you can get electricity easily because it's connected to the blue wire, but now it's off. So if you see, if we put this wire here, it will start electrocuting people. For example, I'm not gonna touch it. So this is the project we have made. Thank you.
Well, thank you for the presentation. Now may I call upon stage 8, the first group, which is going to make a presentation on the volcanic eruption model. Stage 8, first group, may you please come on stage.
Following now, make the crust heater and create a magma flow. Example, Mauna Loa located in the state of Hawaii in the Pacific Ocean.
3. Divergent plate boundaries. It is when tectonic plates move apart from each other that creates tiny space. A hot metal rises up to the little space, reaching to the surface. As the pressure decreases, the hot metal turns to the rock. Structure. The volcano is a cone-shaped landform. The three main parts of the volcano are the chamber that stores magma, the vent is where lava, gases, and other materials erupt. The crater is a bowl-shaped depression where it is placed and lies above the vent.
Where can they be found? According to the National Oceanic and Atmospheric Administration, 60% of all active volcanoes occur at the boundaries between tectonic segments.
5. Types of volcano. 8. Cinder cones. Cinder cones are the most common volcanoes. They're formed by pyroclastic materials such as volcanic ashes, volcanic clinkers, pieces of solidified lava, hot gases, and pumice. They are tall and they have usually a bowl-shaped crater at the top. Also, when they turn dormant, they never erupt again. Example, Parincuti located in the Mexican state of Michoacán. E. Composite volcanoes. Composite volcanoes, also known as structural volcanoes, are formed by successive eruption of dome, lava flow, and pyroclastic flows. This volcano is cone-shaped, tall, symmetrical, and has each size. Example, the Mount St. California. C. Shield volcano. As the name describes, this volcano looks like a shield lying on the ground. These volcanoes have sloppy sides formed by lava that flow out from the base. They're wider and tall. Shield volcanoes are formed by erosion of fluid lava that is viscous. Example, volcanic Galapagos Island. D. Lava domes. Lava domes volcanoes, also known as volcanic domes, have a circular mound-shaped structure. They made from silicic lava such as dacite, rare dacite, or rhyolite. They are formed by division lava rocks from the volcano. Like the lava fatigue, it doesn't go too far and greater dome. Example, Nova Rosa located on the Alaska Peninsula. Types of eruptions. Here are two main types of eruption. A. Effusive eruption. An effusive eruption is when a volcano erupts lava that flows out of a volcano onto the ground. This eruption has a magma of about 1,200 degrees and the dissolved gases escape easily.
B. Explosive eruption. An explosive eruption is when a volcano around shoots gas and fragments of broken magma and ashes into the atmosphere.
Now we're going to do the experiment. Yes, experiment in a volcano eruption. So step one, we will put the baking soda. Can we put it?
Yes.
Yes. Perfect. Like this.
Ain't a lot.
Okay, that's two. We pour the vinegar. Yeah. No problem. Yes, Conclusion. To conclude, volcanoes have different ways to be formed. They have a structure. They are formed at the boundaries between tectonic plates. They have different types of volcanoes like shield volcanoes and different types of eruptions. They have their benefits but also their disadvantages. Thank you. Goodbye.
That was stage 8, group 1. Thank you so much for the volcanic eruption model. Now we have stage 8, group 2, who are going to make the presentation for the solar system model. Stage 8, group 2.
Para casamento, né? Fiz uma lente. Vocês já sabem esse colégio. Aquele que não faz muito longo. Quando for muito bravo, é muito.
Good afternoon, parents. This is a room campaign that consists of me, Mohammed, and we're going to present a model of the solar system. So, what is the solar system? A solar system is a group of planets which are surrounding a star rotating around it to form an orbit.
Our solar system can contain many celestial objects, including planets, asteroids, and suns. As you can see on our model, 8 planets in our solar system, including Earth as well as the Sun. Now, what are these planets?
Planets are a group of dust and rocks which are formed to create these rocks that we call planets.
There are many different types of planets, and in our solar system, there are 3 types of planets. The first 4 planets you can see here, Mercury, Venus, Mars, are called, as you can see, Jupiter and Saturn over here are the biggest in our solar system. They are also called or referred to as gas giants. This is due to their mainly composure of gases. And the last 2 planets in the solar system, Venus and Neptune, are called ice giants. This is due to a lot of amount of ice on the surface, which is caused by the distance from the sun, as you can see with that line.
Thank you for listening. That was a presentation.
Thank you so much, group 2, stage 8. Now may I call upon group 3, stage 8, who are going to show us the model of the heart. Stage 8, group 3.
gentlemen, and then we're going to present how the heart is structured.
My name is Chikon Kanda.
And my name is Janice Asinta.
The heart is divided into four chambers, which has two different chambers on the top and the bottom. The right atrium has two large veins, which deliver oxygen to our right atrium. The superior vena cava carries blood to your arm.
Our heart is divided into the superior vena cava, aorta, left pulmonary artery, left atrium, left ventricle, right ventricle, and inferior vena cava. So, the blood flows from the superior vena cava to the left atrium, moving from the other side, and the left pulmonary arteries moves the blood and flows to the aorta, moving to the other side of the heart. So, once our blood is weak, we may develop many heart diseases, and our heart may be weak, not being able to function well and do daily routines which demand a lot of energy.
So we're going to demonstrate how it works. So when the blood
moves from this side to the other side, we see
and the other blood moves like this.
These are some of the accidents that happen when we are having experiments. Now may I call upon stage 8, group number 4, which is going to make a demonstration about the solar system. Stage 8, group 4, please come on stage.
Good morning, everybody. I'm here to present about the solar system. First, we're going to define the term solar system. Solar system is the sun and the planets the state of its orbit. The solar system has one star, 8 planets, and 5 planets, and at least 290 moons.
more than 1.3 million asteroids and about 3,900 comets, all accumulated. The solar system includes everything that is gravitationally drawn onto the sun's orbit and a small orbit. Astronomers have discovered there are many other black stars within our galaxy. The Milky Way uses the resource to teach students about the objects and relationships within our solar system. Details about the solar system. We call the solar system because it is made of and millions of asteroids, comets, and meteoroids. The order of the planets in the solar system, starting with the nearest, is the Sun, and the working outward is the following: Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, and then the possible planets.
Final conclusion of this planet. Final conclusion of this solar system holds as a temperature materialized by specific planetary structural cosmos, symbolizing the soft and red planets.
Thank you.
Thank you so much for your presentation about the solar system. Now, may I call upon stage 9, who are going to make a demonstration on an electric door alarm or electric door buzzer. Stage 8. Stage 9, sorry.
Check.
Good afternoon, parents, teachers, and my fellow students. This is my group and we are here.
Which one? First. Which one first?
Good afternoon, parents, teachers, and my fellow students. This is my group and we are here to present the topic of design of us to create this time.
As you can see, this inspired me. I've been inspired because of due to heat. Students have been facing, and we're going to suffer.
In order to solve this solution, we created this handheld fan. You can take it basically anywhere, and you can keep it with you at all times. This is just a good way to keep cool and breathe throughout all time.
Alright, wait. The slide is still going. Okay.
So here we have seen the diagram how we created this fan. There is a motor which we use from a lamp, and then there is a motor which we use from a lamp. There's a capacitor or a motherboard which we use also from a lamp, and there is a cable which we use to connect to turn it off or on during the process of turning on the fan.
This is our product right here in action, and we are going to test it in front of you. Now, this is how it's built.
So these are the people. So we have to why we made this is to make our design improve and to make it more faster and
To improve this design, we need to include more voltage of power supply to this fan, and then we will also need to design bigger blades of the fan in order to provide fresh, cool air. Thank you for your attention.
Another one.
Locate clinic goes to the second project of Station 9 group as the door of as a siren for people.
Now we'll head on for another project that we have also made. Now this project consists of a door siren or a doorbell, however you want to call it.
The topic is design of a battery powered alarm system and is made by the Stage 9 class.
Wait.
Sorry for the inconvenience.
It's too much.
Here is our second project, design of a battery powered alarm system. It is made by the Stage 9 class. So the problem here is, as in apartments or condominiums, there are doors and then sometimes they don't have signals. Therefore, the guests when they arrive, they hit on the doors and end up breaking them. They also tend to throw rocks at the roofs, thereby vandalizing the property. Therefore, we have come up with a simpler design to just use an alarm bell to signal when there are guests on the door.
So we made this as a alarm to create signal. Anyone is harmed, you can reach it, open the bell. This will help with this will help with direction. This will help with
So for the solution, we have various camera station on each side. We need to design electrical circuits that use this type of design to make an alarm system.
One of the teachers, 我们混子的上面，好不好？